Hello and welcome to the channel. Okay, so today we are looking at the Band Surfer VFO. This is a VFO we developed in previous videos, and we've basically been building these up on circuit boards. Now I have these available for a small charge, and the parts that go on there are quite inexpensive. This is using the ESP32-S3. Now this video has the code for this that's in the description. I know a lot of people have been after it. I've been quite busy and I've been coding in my spare time, and as you can imagine it's quite time consuming to get right. But I'm quite happy where it is at the moment. We've still got features we can add to it, but it's getting there. So let's have a quick run through. For those who haven't seen any of the previous videos, this is basically a variable frequency oscillator. Obviously we're using a microcontroller and we're producing frequencies using an SI5351 breakout board. And before this we actually did quite a bit of development using the Arduino Nano, which incidentally will fit into this board as well, so it'll take either or of those microcontrollers, the ESP32-S3 or the Arduino Nano or clone, as I was using. So from where we left off, we basically populated all the other bits. So I've put this LM358 in here. Now that's just an amplifier, because you can see on here we have got a bar graph display, and that's to pick up the signals, amplify them so they're large enough to be read by the analog to digital converters in the microcontroller. And we can adjust the level at this point here. Now this is looks like it's turned down, so we may have to change this to a lower value, but we'll look at that as we go on. But these features are pretty much the same as the old system. However, it's a dual VFO system, so we've got VFO A, VFO B, and they're totally independent, so we can go up through the bands. And then we can change over to VFO A and do the same, so wherever you were, get that the same. You can literally 50 megs, 21 megs. Okay, and there's another thing that this thing can do. These are the features, I'll go through them quickly. So here we've got a split. So at the moment we're on VFO B, and it's RXB, TXB. And if we go over onto VFO A, it shows us that we're receiving on A and transmitting on A. However, if we hold the VFO down for 2 seconds, you see that changes colour, and now what it's saying is it receives on A and transmits on B. And similarly, if we once the split's engaged, so if we switch over to VFO B now rather, it's receive on B, transmit on A, so the split stays on. And just to demonstrate this, obviously, as we went through in the previous videos, these are the sense cables. So these go into the radio and sense what mode we're in. I'm just supplying them with a bench power supply at the moment. So if I take the TX high, you can see we're transmitting on 50 megs. This is a bit of an odd one. And we're actually displaying a watt meter instead of an S meter. So yeah, as you can see, so this literally just ties onto the TX8 of the radio equipment, or if you're making home brew equipment, it just needs to go high. I think it's anything over 5 volts, and it'll take up to about 16 volts. No problem, it won't damage anything. So the other thing we've got added on here is this module over here. I'm not sure if you can see that. This is the FRAM, or FRAM as I call it, and what it is, it's 256 kilobit, 32 kilobyte. It's RAM, random access memory, but it's ferrous, so it doesn't need a battery backup, and it holds all the information. So we send data to it via I2C. Now this is designed to go onto the underside of here. It actually solders in. I've just got this one out because I've been playing with it. But that just solders onto the underside of the board. If I can show you on here, if you look here, yeah, you can see that's where the FRAM module sits, and it just sits up there like so. Okay, so we can turn that off. We press and hold for 2 seconds, and you see it's now gone off. Also, we have, people who say, can we put a lock on it? So obviously we can tune. So if you hold the tuning step, the speed for 2 seconds, it tells you it's locked. And if you try and adjust the thing, it won't do anything. And if you just momentarily press it again, it'll unlock it. So it's now unlocked and we can tune. Okay, and other features that we've got on here, we've got this board. You probably wonder what this is. Well, these are boards produced by Adafruit. I really like them. They've got the limitations, but I love the concept, and I really like Adafruit, designs and stuff, and the things they come out with. They're really cool. So what this is a rotary encoder. But it's a board, so what it's got on there is a little microcontroller. And basically what this does, it's a little seesaw microcontroller. They put a program on there, and this, basically detects, the quality information coming from rotary encoder, and then squirts the information up the I2C bus, which I've got it connected here, and we can use it. And you can cascade these as well, which is really neat. Now there's a little, if you look underneath, there's a little section here. Now you just solder links over them, and what it does in different combinations, you basically changing the I2C address. Of course, we've got to keep them unique on the I2C bus. This is a bronze rotary encoder. I think it's about 24 detent and 24 pulses per revolution. So if we press it, it's got a switch on it, so we press the switch. This is for the 11-meter aficionados. It puts it into channel mode. So in channel mode, we've got this. We can, if you notice, I can still tune with the VFO, but if you tune this, it just corrects it again. It just puts it back into the correct frequency, and we can go through our bands. Now, I don't know much about 11 meters, if I'm honest. I'm certainly not an expert. I mean, I've got total respect for people who have. Don't get me wrong. But if there's features on here that people think should be on it, let me know in the comments, please. But I thought it was pretty cool. So I've got low FCC, which is the normal 40 channels. Then we've got mid, and then we've got high. And then if you press it again, it goes on to the UK FM, because here in the UK we have got very funny frequencies for some reason. I'm not quite sure why that is. And obviously we can change the channels via using this rotary encoder. Now if you see that thing flashing up there, it's because I'm sharing a GPIO with something on the microcontroller that's got that NeoPixel on there. It's fine. I actually have got to quite like it, but it seems a bit random when it comes on. It doesn't affect anything. So, if you see that, there's quite a bright one there. If you see that, then, just be aware that's what's happening. But yeah, we can adjust the channels. And if we go up again, I put Japan in there. Because I've found some frequencies. I'm hoping they're the right frequencies. I mean, I just got them off the internet. So... and I've programmed it into it. So now in Japan they only seem to get 8 channels on there. It would appear so. That's all they get, 8 channels. Which I'd say is a bit odd considering Japan, but they are very minimalistic people. But they're really sort of very good at doing a lot with very little, and hence why I like their electronics. But yeah, that's the channels. So yeah, we can we can use the rotary encoder so you can actually tune away from the channel, but when you change the channel, you know, it corrects it. It'll just jump back to what it should be. So if we press that again, yep, that just drops us back into normal operation. Okay, there's another cool thing you can see on here. We've actually got the Wi-Fi working. This has got a board on there, so I've got some code in there. We're actually connecting up to the Wi-Fi. Now I'm just connecting up to the hotspot on my phone, which isn't, it keeps dropping out, but that's what they do on these iPhones. But you can connect it to your home Wi-Fi. You know, it's not a problem to a router. Or router, whatever you like to call them. And yeah, and what we're displaying here is UTC. So this is getting this off a server on the internet. So there's a little program we can put in there, and you can put the correct time in there if you want to, and do a offset and daylight savings and whatever. But I've just got it running UTC. It's just like universal time, or GMT, it's the same thing. And another cool thing we can do with this is if we switch the power off, switch it off, switch it back on. There we go. Yeah, and it's locked on to the time. So it just sometimes takes a bit of time to initialize the thing, but it comes back exactly as we left it. So wherever we tune, or whatever band we're on, let's just change the bands about a bit. So leave it like that, and we switch it off, switch it back on. We're back exactly where we left it, and we're waiting again for this thing to. I know it's something I may have to look at, but you can turn this feature off if you find it annoying. Yeah, there we go. It's done it, and it was similarly. You know, if you're on. You know, if you're in channel mode and, you know, you're on, say, FCC, what's a channel 19? You know, we've got it there. You switch it off, switch it back on, comes back in channel mode, and we'll wait for it. There we go. And it drops in. Now, there's just a little bit of lag. Now, all that lag is to do with is this time clock. So what happens is, before the router makes connection, it seems to down the I2C bus. Now, it's the thing with the ESP32s, I'm looking at it, but you don't have to have this function on. I just thought I'd put it on. I thought it's a nice little touch there, but it's quite useful. But the main thing about it is not the time, it's that we're able to communicate with this unit via the network, i.e. via Wi-Fi. And so I could actually write programs where we can actually control it, or that will patch into this using something like Ham Radio Deluxe, so that you can sort of connect up to it. There's a mend function on here at the moment. You press that, it's not doing very much. We're actually doing nothing because I haven't programmed that yet. So, but that's about it. And this is similarly, you know, for the memories. You know, it doesn't matter what speed you are and where. You know what, you know, it'll remember, you know, what VFO setting you were on. It'll remember what speed and what your tuning steps are. You know, if you just switch that off, switch it back on. There we go. Yeah, it's exactly as we left it. So it just saves everything. And, you know, you'll be able to put memories in here, you know, to sort this out. Now, at the moment, obviously, everything, all the configuration's done in the code. Now, we've got a section, we'll look at that later. But, you know, obviously, this has got IF offsets. We've said this before, but if somebody's haven't seen the previous videos, you know, we can control radios with this. So the next thing to do is get this thing connected up to radio and just see how well it's performing. Okay, so we've got this connected up to an old 11 meter radio. This is from the late 70s, early 80s. You know, obviously we are replacing its internal synthesized local oscillators. Obviously, in these things, they're really dated sort of synthesizers. Yeah, they're an innovation in their day, but they're very limited. So I think this is an ideal candidate for testing. So the rest of the circuitry is all analog, so it's very easy to control. They actually receive quite well, and they do work reasonably well for the component count. The component count's quite low, very clever. But yeah, it's good. So we're connected up via the coax here, which is all good. We're also connected up to sensing our mode. So there's just some circuitry inside. So if I adjust the mode, don't block the screen, you can see it's sensing which mode we're in. Now that's important, not just for the display, because we've got offsets. This particular radio needs a 3 kilohertz offset for when it's in lower sideband, otherwise it will be off frequency. But that's, we've done it in the code, we've picked that up. We're also picking up the signal level. So I've just disconnected the meter and it comes in on this one here into the unit, and again we can adjust the level here. There's a bit of a trick to doing this, but I'll put a sheet together on how to set this up. So let's have a look. Don't seem to have a lot happening. This is 10 meters. Now, of course, we're only going to be able to sort of receive within the operational range of this radio, because obviously this has got a front end. It's connected to an antenna, but it's got a front end and it's tuned for 27, 28 megs. But yeah, I thought it was a good little illustration. And of course we can tune. Now somebody said they didn't get smooth tuning. Now you should get smooth tuning. The only thing I could think it is that you haven't got the SI5351 calibrated properly. Now I have got a video on how to do that. You need the calibration figure to make this thing run smooth, because how it works, it will just get jittery as you change the frequency because they're slightly off. But that's okay, that's fine. I seem to be getting something on channel 6. I did. Okay, so there's more we can do with this. So, obviously, as I said before, we're limited, because if we go down the bands, go out away from 28 megs, you can see it just goes dead as a doornail. But simply because we've got something there, but simply because we're outside of the tuning range of the front end of the radio. So there is something we can do. Now, I haven't done this before, but using a mixer, I reckon we can use this as a transverter. So basically using one of these cheap little mixers, what I plan to do is connect a fixed signal up to here. So I'll give this a fixed frequency, say 28 megs. So that's what it receives. We can send a variable frequency oscillator from one of these to the mixer, connect the antenna on one side. I mean, it should have a mixer on there, but it should have a filter on it, but we'll try it with and without and see what we get. And we'll connect the IF out to the antenna socket on the back of the radio, and this should transvert, so we should be able to get the other bands. So let's give it a go. Okay, so we've got this thing connected up. So I've got the mixer connected, as we said. So we've set in the code the IF to 28 megahertz. and the local oscillator is coming up here and going into the mix part of the mixer, and we're sending a fixed frequency up to the radio, so it's essentially locked on 28 megs, which is, this has got a 10.695 megahertz IF. It's a down conversion radio, so we have to add that to the frequency, so that would be 39.695 megs fixed. So this will be receiving exactly 28 megs, and it's basically acting as an IF. So essentially what we've done, you know, this has now turned into a triple conversion receiver. And also we've got our antenna connected here without any filtering at all. Now I can tell you this does work. I've just been playing with it. It does work extremely well. And you know, traditionally, you know, a mixer would be overloaded, but these analog 831 AD831 mixers really do manage to cope with a lot of signals. There's quite a bit of gain in there as well, so you don't really need a preamp. So yeah, they work incredibly well. So this needs 9 volts. We're just getting the 9 volts here from the unit. That's what this is for. There's a little 9 volt reggae on there, especially for doing this. So okay, so we're going to connect up to the radio. We're currently tuned to the medium wave band. You can see we are end stopping. It's being end stopped. And if you listen, it's one of our local AM radio stations. It's the country hour by the sound of it. I want to be careful. I don't want to get a copyright strike. So we're on AM. This has obviously got there's a ceramic filter in these. I think it's about six or thereabouts kilohertz bandwidth. So you're not going to get the full bandwidth of AM stations. But I'm surprised at how well it works. These are really strong signals. Obviously it's end stopping it. And it's not calibrated. You know, you'd have to set the signal levels because we're putting more gain on the front of the radio. We'll find some more stations. It's another local one. Now, there's another thing on here which I didn't show you. I wonder if as many CB radios have received this low. We're down into this is low wave now, so into kilohertz. But there's another feature on here I want to show you. I forgot to mention it. So if we take a look, let's see if we can find a quiet spot in the band. Here we go. Well, that's if you're going to get somewhere that's quiet. Okay. Let's just turn that down a touch. I've got this potentiometer here. Now what this is the squelch. And if we look on the screen, obviously we've got our meter. And if I turn this, you see this grey mark come up. Now that is the squelch level. And it's in tune with obviously what's on the display. So if we go past we can actually squelch out. Now we do get a bit of popping with this. It's just the nature of this radio. It does pop. You know, these Cybernet boards. There is a mod you could do. I'm not really that interested in it, to be honest. But you can see it greys out, and when you come back, and you can see. So it's nice to see. You know, it's really nice to see on a display. You know, the signal level against the squelch, because on a lot of radios you don't see that. But you can see as it goes past, you know, it turns green again. And there's another thing on this meter that's pretty neat. I put a peak marker on there. So it's got a 3 second, I think I've set it at 3 seconds. And it will stay up, and then after it peaks, it'll drop back down. So you're going to do it. No, there we go. So it just, you know, it's a good indication. You can see where your peaks are. Now, there is a bit of calibration routine to get this thing to work properly. I think I need to write some more code on it because, you know, on most radios, they're not very accurate. You know, they're normally set to S9, and then they just because the signals coming back from the radio obviously are not linear. I mean, it's not going to be linear because, you know, we're picking up information, you know, which is subject to the inverse square law. But then we've got AGC on top of that, which starts, you know, and if you want to start plotting curves and stuff, you get weird and wonderful things happening. So I'm going to have to write some kind of algorithm to combat this. I'm sure I can. You know, it's just a case of injecting a number of different signal levels and then telling the algorithm what it should be displaying, and then it should go away and do its thing. But I need to think about it and play around with it a bit more. But yeah, it's something for the future. Okay, let's have a play around on the band. So, well, let's. You can see these are extremely. I don't want to get a copyright strike. So, let's go up. Now, I've set this to up conversion. And the reason I've done that is so we keep lower sideband and upper sideband the same. Otherwise, it'll be the other way around, because I know it gets a bit complicated, but what happens is if you down convert, and if you're reading the down converted signal when your local oscillator is higher than the signal that you're receiving, it transposes the image, you know, on the down converter side. So what you'll see is lower sideband will be upper sideband will be lower sideband. So, but if you do it the other way, up convert it, then we don't get that problem. And because we're using the mixer, we've got the choice. As long as we're getting, you know, our IF comes out as we're doing here at 28 megs. So let's have a play around. So let's have a look on lower sideband. Course on the tuning, let's get down to 10 kilohertz. Ooh. Okay, and there is another thing we can do. Obviously, because we're at 28 megs, we can actually just connect up an RTLSDR dongle. You could just tap onto the IF, and yeah, you would see what's on the band. I've done that before in previous videos, so I'm not going to bother doing it. But yeah, quite easy to do. You just tap onto the IF. Now, one word of caution. It's foolhardy to connect a mixer onto the antenna socket of a transceiver, because if that goes into transmit, and these things can go into transmit when you switch them on, I've got it inhibited at the moment, and if it gets RF up here, it will blow the mixer. It's yeah, it's bye-byes to the mixer, because yeah, I'm sure it won't take any you know, reverse RF of any sort of level. But that's it. Okay, so next thing we're going to do, let's get into the code. I'll show you how to configure the IDE. We'll look at the libraries you need to install and how to, configure this for, obviously whatever your application is. Okay, so we're using the Arduino IDE to program this. So the version I am using, let's have a look. Yeah, it's 2.3.2. Yeah, I know people have problems with older revisions of this. I haven't tested this on older revisions, so I would recommend that you get the latest version. I believe this is the latest version. Well, it certainly is at the time of making this video. Okay, so you need to download the zip file, which is available from the description, and it's basically here. And what we want to do is basically right click, and we'll just copy that. So we'll just, if we go back up again, you've got the zip. We right click, so we go into it, and what we do, we copy the folder, not the zip file. We want the folder. And if you just have a quick peek in there, you can see there's a lot of these different things in here. These are just files. So we've got header files and we've got source code, C++ files. That's what CPP stands for. And also, if we check in here, we've got a readme.txt. So let's just open that. Now what I've done, I've put together, it's just a list of what you need. I'm going to go through it, but what I'll do, we'll go through it. We'll go through it together. Okay, so let's have a look at our IDE. So if I just move this over to this side and try and make it. Oh. Okay, that's better. Okay, so we've got our Arduino IDE, and what the first thing we want to do is make this IDE compatible with the ESP32. Now, this board uses the development boards. I've gone through this in different videos, so you need to get the right board. It's an S3, and there's links in the description showing you where you can buy, or but you'll get an idea of exactly what we're using. So if we look at this side on here, to configure it, we need to get this URL here. So this goes to GitHub, and basically what it is, it's expressive, and they've done, there's a JSON file. It's a JSON, simply it's a JavaScript file. So what we do, we go to our IDE, we go to preferences, and if we look here, we've got additional boards manager URLs. Now I've already got this in here, so if we just have a look through that, you can see I've pasted it in. You just literally paste it in. Now if there is something already in here, what you do, you go to the end of the file, put a comma and a space, and then hit paste and put the code in. But I've already got this in. I've got no other packages on there. So then you just hit OK, and then it will start compiling. And well, it's compiling when it's configuring the system. It may take a short while, but once it's done, it will tell you. Okay, so the next thing to do is go to the boards manager. So you need to go tools, come down, it says board. Now we've already got the module installed. I want to come across here to boards manager, and it opens up this box here. And what we do, I've already searched for it, so we just type in ESP32, and then we have to come down. It's by Expressive Systems, and the one I'm using is 2.1.4, and we just basically hit install. I've already got it installed, so that's why it's only giving me a remove option. Okay, so then the next job is to go to select board. Now you can see I've already got this in there, but that's the one we're looking for. It's ESP32-S3. And if we go down through, because there's quite a lot here, this is the one you want, ESP32-S3 dev module, and there's a little tick there. And we can also, this side, select the port. So if you've got it plugged in, it will, you'll see a port up there. Okay, so once we've got that installed, the next job, let's have a look at our list. We can see we've got to install these libraries. Now, we've gone through this in previous videos, so you want easy button, and you can see the version numbers. So if we just take the first one here, copy it, and if I go up to the library manager here, hit paste, you can see easy button, and it's 1.0.4. Now I'm not going to go through all these, they're all self-explanatory. If one thing I will say, some of them will ask you to install the dependencies. You hit yes. If you hit no, they won't work properly, and the way to get them fixed, you have to go back, uninstall, remove it, and then install it again, and it'll give you the option to install the dependencies. So if we look on our readme file, they're all in here. So you've got U8G2 LED controller. Now you've got to make sure you've got to install all of these. It doesn't matter if you're not using them, they need to be installed. They won't get compiled if you're not using them. However, they need to be installed, otherwise the system won't compile and come up with errors, because it'll look for them and it won't be able to find them. So I've put the name and the version numbers I'm using. If you keep it the same, it'll work. Obviously, revisions change. They improve the libraries, but sometimes we lose functionality. So to be sure, when you get started, just use the correct versions, or the same versions that I've used. Okay, so if we get back to our file, so we'll go back up again. I know I've done this before, but if we go in, that's a zip file. We go into the zip file, and we've got this folder which has got all these files in here. We'll go back up. So what we want is just to copy this folder, and then we go into our IDE. Now the reason I do this is because the paths are all different, and I recommend you just use the standard path, the default path that Arduino provides. So if we just hit open, it should take you to where your sketches are. You may have a different configuration, but so in here we just literally right click, and then we hit paste, and that will paste it in. Now I've already got it here. You'll see we've got Band Surfer, and that is the version 1-0. Now I've got these on here. When I add more features, the version, we're at 1 at the moment, it'll change to 2 with more features, and the 0 will increase on each one every time I do a bug fix or a patch. It'll, so from this you'll be able to figure out, hopefully, you've got the latest version. So if we look inside this folder, you'll see this. You won't see all the other folders because it's only looking for an INO file, and you literally just double click on it, and or just click on it and then hit open, and you will wind up with, let's bring this up, you will wind up with the file that looks like this. Now, as you see, we've got all these tabs along the top here. Now these are all different classes. I've done this, and this is why it's taken me quite a bit of time. So we've got the core program of the Band Surfer, which is basically all this lot that sits and runs. There's a number of functions down here, and then it calls these different classes. So I've done this so to try and not clutter the program. So let's just go through it. So if we look between these bars, as we mentioned before, we've got these bars. This is, I've called it a user definable area. So basically, you know, we've got these defined macros. Now, what these are, and you've got the little, strikeouts, just simply means that it, when it goes to compile, it'll just ignore them. But what they do, they switch in sections of code. So if you're not using certain things, don't bring them in, because, you're just wasting CPU time. So if this is the Max 7219, that's the 7-segment display, which we covered in previous videos. If you want to use that, you literally just, make sure it's defined. So it's 2 strikes or more for the compiler to, obviously not read it. If you put 1 strike in, you'll get an error when you go to compile. And similarly, we've got the SSD1306 display. That's as the OLED, so that's to bring that one. We're using the ILI 9341 display, and that's the macro I've got switched on for it. We've got clock 1 enable. I know we're using it, but I haven't finished that in the sketch. That's something that will come out with the next revision. And we've got a dot matrix LCD, which again, I'm still writing for the ESP32. And we've got a thing called channel set. Now, channel set is if you want to channelize the radio, and we've had it channelized, but that we use those Adafruit boards, the encoder boards, and that is the one that you uncheck so we define it. Now, if you're not using channel set and you haven't got a board, don't put this in, because what will happen is when you boot the system, when you boot the Band Surfer, when it goes through, it will drop automatically into channel mode. It's something I've got to look at, but that's what it's doing. And if you haven't got the encoder, the little encoder board in there, and you won't be able to switch it off, so you're stuck. So the simple thing is don't include it if you haven't got the board. Now there are addresses. Now I've just on that encoder we looked at the addresses. I haven't got anything on there, and this is set to the default address. If you come down, we've got VFO lock. Now that shouldn't really be on a macro. That should just be on a Boolean variable. But I'll change that later. I don't know what I was thinking when I did that, but if you just strike it out, it just means the lock function when you hold the spree button won't work, and so leave that in. And we've got one here. This is the SI5351. It's just got an X on it. Now you don't have to install that library with this version because it's already included. So you just leave that defined. And if you want to use UTC time, as you can see, you can bring it in now. If you haven't got it connected to a router, the system will hang while it's trying to find the router. So I'd recommend that you just leave that out to start with, and then you start messing around. We can play around with it as you get the system going. And similarly, we've got FRAM. Now this is for this is for the Ferris Random Access Memory, or FRAM as they call it. So if you're using it, leave it in, and if you haven't got it installed, strike it out. That's it. Okay, so we'll just talk about some of these. If we come down to here, I'll talk about some of this setup. So between these bars, we can actually set things now. Ultimately, I'm going to put these into menus so that it can be menu configured. But I'm going to do that at the end. There's still quite a bit more developing, and there's more features I want to put onto this thing. So my idea is to just leave it like this to start with. So we've got the top here, we've got LED brightness. That's if you're using the Max 7219. You can adjust the brightness here. And that is between a range of 1 and 15. Or I think it goes from 0 to 15. I think 0 is off, and then the brightness will step up. They're not terribly bright on a 3.3 volt system, which the ESP is 3.3 volts. but they are much brighter when you use the Nano, because that's a 5-volt system. Okay, we've got our IF frequency. Now we've been playing with this because I set this to 28 megahertz. So you have to put this in hertz, so 28 and then 6 noughts, but whatever IF frequency you want. Then we come down, we've got a number of bands. We've covered this in what's saying, but these are the default bands. So, you know, these are arrays, and basically what we've got here is, you know, the first one, as you can see, it says 27 megahertz, because obviously it's all in hertz. Now this is for channels, so that occupies, the frequency occupies in there. So you don't worry about configuring that, just leave that alone. And if you want to change the name of your bands, they correspond, so if you count them, so this is 1, 2, 3, 4, 5, you know, which is medium wave. This is 160 meters, this is 80 meters, and here you go, 160 meters, 80 meters. So you can change the name of the bands and it will come up there, but just be aware if you make them too long, it might be a bit too big for the display, but you can play around with those. But that's the defaults, you know, so I just leave them when you get started. And we've got this up-down conversion section here. So we're currently using up conversion, which means we put a minus there and -1, and if it's down conversion we just leave it as 1. And if you've got your encoders going the wrong way, you can either change the green and yellow wires around, that's the A and B, and then it should work the right way. So what I mean by this is if you turn the encoder and the frequency, you know, if you turn it clockwise and the frequency starts going down, you need to invert it. So basically what you do is just make that true, and that'll invert it. Or as I say, just swap the green and yellow wires around. We've got this is a bar meter level, basically 2.4, and so we can actually change that. I think that's a bit high, but that is to calibrate the level on the meter. It's going to be quite tedious doing it this way, because you'll change a little bit and then you have to upload it and then change it a bit more and then upload it. Eventually, as I say, it will be all on menus, and there'll be a calibration routine, you know, in there for it. But at this stage, this is how it works. We've got the calibration SI5351. Now this is really important. I've actually made a video going through this. You need to get that figure, you need to get it in there. Not only because it's a frequency issue, you'll get jitter when you tune in, because as the dividers work, the off, you know, some of the frequencies will be off to each other. So yeah, that's vitally important. You know, you need to do the calibration routine. Okay, we come back down. We've got FRAM I2C address. Now, if you don't know what the address, I think the default's 50. Mine's a bit different. So yeah, what you want to do is probably just do an I2C scan on it. I showed you how to do that in the first videos. So we just basically, you know, go in there and change and do a scan and find out what it is. Now you'll get two hexadecimal addresses back from a FRAM, because one of them is the FRAM, and the other one, it's got some EEPROM in there, and that's, you address that separately. So it has two addresses on the I2C. We're only using, at this point, we're only using the FRAM, so it's 50 something, and I think it comes out, you know, at 50. But you'll figure it out, that's not a problem. And if we come down to here, we've got Wi-Fi SSD, and between these inverted brackets you put in, you know, the name of your router, and at this point you put your password in there, and then obviously when it uploads, it just, the Wi-Fi, you know, section of the ESP32 knows how to connect to your router or router. Okay, and then if we come down, we've got display mode. Now, I've covered these in the other videos, you know, mode, display mode. It just shows you what mode you're in, you know, whether you want it to show, and if you want the shifts, as we covered in the previous videos, we can actually put frequency shifts in here. And if we come down here you can see AM, FM, upper, lower sideband. It just simply means when you go into that mode, the local oscillator will shift by the amount you put in here. Now this is all in hertz. If you want a negative number, so if you want to reduce it, as we are in this case for lower sideband, you just put it in, and so that's 3 kilohertz, which is 3000 hertz. Again, these are all intuitive. RX, if you want to see the RXTX symbol on the front, you hit true. If you don't, just hit false. And we've got a TX shift enable. Now, simply all this is that, some radio equipment, or you may design your own radio equipment, you may require a shift on the main local oscillator when you're going to transmit, and some radios do. It can be tens of megahertz, depending on how they've configured. You just make that true, and then actually put the shift from the main LO, what you want it to shift by, and you actually, you just put that figure in here. Again, it could be a positive or a negative number. And then we've got this section here, which I've left fault. These are all the general settings. So most of the time, this is how you're going to have it set. We've got mode shift TX enable. So we talked about that we could actually shift the LO frequencies by, depending on which mode it's in. Maybe you don't want to do that when you're going to transmit, so you just make that false. Mode shift enabling TX with the Cybernet board. With to do it, we should make that true. So I'll almost make that true because it still needs the same offset. We've got squelch enabled, so if you want to use a squelch control, you make this true. If you haven't got a squelch control on there, make it false. And if make sure you set that to false if you're not using the squelch control, simply because what it does is an analog to digital pin that will just be floating, and what it'll do, you may see a bit of noise coming up on the display. It's just noise it's picking up, so it won't look at the pin. The analog to digital converter won't even switch it on, so if it's false. So we make sure that's true, and we do they've got a reset. Now, we spoke about the FRAM, so this is quite important. If you're going to use FRAM, you need to make sure this is defined, and when you first upload this to the Arduino, you need to make sure this is true. So if you're using FRAM, the first time you do it, you make it for what it does. It initializes and puts all the default information into the FRAM. So we need to make it true. So once it's uploaded, it goes up there and it's done. And then once you've uploaded it, we come back here, we type false, because it won't update anything. So what it'll do, it'll just keep trying to write the defaults in. So we now write false and then upload it again, and then that will initialize the FRAM and it will start working. So it just means that it will automatically start saving all the modes that you had the thing set in. So your frequency, what VFOs and and all that good stuff. So that all goes into there. It's all mapped out. It all works. Now, future videos, I'm going to probably do a bit more in the mapping on that, because it's a bit rough and ready at the moment, but it works fine. It's perfect. I just want to manage it a bit better than I have. I've just put it together in a bit of a rush to get this thing working. So it's nothing to worry about. It's fine. But that's basically it. So, if you get any problems, let me know in the comments. See how you get on with it. If you think there's some features you'd like to see in there that would be worthwhile and helpful, again, leave me a comment. So as I said, these boards are available. You can get, we'll sell them, at a small charge in shipping. We sell them internationally. My daughter does it. So if you want boards, the printed circuit boards, you just drop us an email. There's information in the description. If you want a fully populated one, Yeah, we will do it for a small charge. It's my daughter will make it for you, and we can put the calibration figures in there as well. I'll give you the calibration figures for the SI5351 module, so it makes things a bit easier. And it gives my daughter some college money. So yeah, that's about it. So as I say, you know, if there's other things, you know, if you're not sure about anything, you know, feel free, drop me an email. You know, when I get time, I'll maybe a bit of time before I can respond, but you know, I will get back to you and we'll see if we can iron the problems out. And it means that you're helping me improve this. So it's quite a fun project. It does work quite well. I'm not trying to blow my own trumpet. Yeah, it does. They do work well. And I'd like to sort of build on it and see what else we can do, because we can use this as a central module and we can start building other cool little gadgets and stuff. Now, eventually, I have been approached by quite a number of people about this, and I've agreed that we'll make the Band Surfer a surface mount version of it. This is for people who want to use it for going, you know, you can use it for various purposes. But it'll be quarter of the size, or probably about a third, if I'm honest, of the size of the one that's in there, because it'll all be surface mount and it'll be pre-manufactured. But if you know, when I get those, I will make it available. But the ones we've got at the moment, they're good for development, they're good for playing around with, and you know, if you're playing with code, it's perfect. I sort of, you know, it's interesting stuff. Yeah, some of it you have to get your head around. The things don't behave exactly as you'd expect them to, but yeah, you'll figure it out. Okay, so if you watched the video to as far as here, I'd like to say thanks for watching. I really appreciate the subscribers that we get. It's really good, and we're getting some good support to the channel. We're now fast approaching 2,000 subscribers. So yeah, things are looking up for the channel. Also as well, if you feel that you could spare a donation, any donations everything goes towards the channel. I did have buy me a coffee. I looked at it and it was after your credit card information, and it's all moody, so I'm removing that from all my things. I don't like it. So there will be a little donation button there for PayPal, and you know, if you fire it, it's much appreciated, and it goes in. Also, there are links in the description to the parts we've used. They are affiliate links for AliExpress. The amount we get back is absolutely minuscule because the parts are very, very cheap, and that's what I sort of recommend people use. Which, you know, I make sure the ones I recommend will work well with it, because there are variations. But again, thanks for watching. We'll catch you in the next video, and let me know how you get on.